The Dummy's Guide to the Microscope. We want to introduce you to the compound light microscope that we use in the laboratory sessions at university. First, catch your microscope. Always hold the microscope by the arm and in an upright position. Bits may fall off otherwise. The light microscope is used to magnify specimens many times larger than their original size. Along with the magnification, a researcher can observe specimens and measure the actual size of the object. Another advantage, living objects can be observed moving. Really cool. From its origin several centuries ago, the light microscope hasn't changed in its basic form, but has evolved in complexity. It still uses light passing through the lenses to magnify the object. Here we have a lovely specimen of a microscope. Extant specimens of microscopes have evolved ocular lenses, where a researcher can look down to observe the subject. The ocular lenses have a magnification of 10 times, which means the object appears 10 times larger than in reality. Quite handy really, but still no great advantage over a much smaller handheld magnifying glass seen here at a fraction of the price. What really sets this microscope apart is the choice of magnifying lenses from 4 times to 10 times to 40 times and 100 times. This means that a researcher can look at objects anywhere from 40 times to 1,000 times larger than the original size. Remember, the ocular lens is 10 times, and you multiply that by the magnification power inscribed on each objective shown here. Learning objectives from this video include basic care, the major components, their uses and functions, and how to magnify your specimen without stuffing it up or annoying your supervisor. Terms like focus and resolution will also be introduced. Basic light microscope operation begins with bringing light to the sample. Therefore, we need to turn the light on. Okay. We also need to identify parts of the microscope. The base,
that one.
the arm, the mechanical stage, spring-loaded slide holder, light intensity controller, the styrofoam lever, the ocular lens, the objectives with the nose piece, correct. Yeah.
There's a nose piece in there.
Now we need a specimen, and here is one on a slide we prepared earlier. Always hold the specimen by the edges. Place your slide on the mechanical stage and hold it securely in place by using clips or the spring-loaded holders on the stage. Centre the specimen over the light source by using the stage controls of the mechanical stage. This allows smooth movement of the specimen. Start with the 4 times objective. Make sure it is in position. Remember to use the nose piece to rotate the objectives. It doesn't look like a nose piece, rather more like a disc. But if you try moving the objects by holding them onto them, you risk damaging them, so please use the peculiar name nose piece. It should click into position. Next, the sample must be magnified properly and brought into focus to view the region of interest. Focusing means obtaining a clear image that isn't blurred. This can be done by using a coarse adjustment knob.
The big one.
This brings the objective closer to the specimen. This is the reason you start with the low power first, as it is the shortest objective and there is little risk of damaging the objective by bringing it down on a glass slide. The knob is turned towards you, that is counterclockwise. When the object is as clear as you can make it by using the coarse knob, then make the slight adjustments by using the fine focusing knob. Once you've located the area of interest, adjust the light strength or styrofoam until the appropriate intensity is reached.